how we can use this algebra, to help us solve some different situations. So 4 tennis courts are arranged as shown. So these are tennis courts, 1, 2, 3, 4. I'd imagine they're the rectangles because a tennis court, if you know, is a rectangle. With a square storage area in the center. There we go. So first of all, whenever I'm reading these questions, I try and make sense of what's going on. Each court has the area dimensions of A by B. Write an expression for the side lengths of the total area. Okay, so when we've got the total side lengths, so we've got to write an expression for the total side lengths of the area. Well, you've got this total square, right, going around the outside. Now, we have each tennis court in here is sort of to about there, and this one goes up to about here, and this goes across here. So we've got like tennis court, 1, 2. So this is a tennis court here. There's another one here, another one here, and another one there. So we want to write an expression to find the total for the side length of the total area. So we just want to find the side length of this one because it's a square. Well, this tennis court, each of them has a length of B, a width of B, and a length of A. We can say like the long length. So this would be B, and this would be A. This would be B, this would be A, this would be B, this would be A. The total width of this would be B plus A, right? So we have to write an expression for the total side, for the side length of the total area. Of the total area, write an expression of the side length for the total area. So expression of the side length, BB plus A. But we want to write it as an expression of the side length for the total area. Well, to find an area of a square is length times width, right? Or this squared, because it's the same thing. It's still A plus B. So you can write it as B plus A or A plus B. It doesn't really matter, squared. Really, though, I would probably write it in alphabetical order first, A plus B, all squared. So either one of those would be what you'd get. And that would show you the area of the total length of the area. So that would be the total area of the whole thing. Write an expression for the total area. Sorry, so the expression for the side length, I was right, would just be A plus B. I moved ahead. I was getting a bit confused with what it was saying. A plus B. For part B, write an expression for the total area. Well, that would be it there, either one of those two. Write an expression for the side length of the inside storage area. We've got to find what this length is, okay, on the inside storage area. That's going to get a little bit tricky, isn't it? Well, if you think about what this side length is, let's just look at, this length here, right? Or you can look at this length here, it doesn't really matter. Well, what length is this? This length here, if you just look at this, so we're just trying to find out, from here to here. Well, if you look at court 2, and a diagram really helps you understand that. We want to know what it is from here to here, right? This is court 2. Well, I know the total length of this thing is A, right? So I know from here to here is A. Now, if you look at court length 3, we know that from here to here is B. So that is B, just from here to here. So we know that that width is B. So this section must be A minus B. Because if we take the length of A and we take away B, we're just going to have this section. So that would be, for the side length of the total internal area would be A, take B. And then I'd imagine now we need to find the area of the square on the inside.
Yeah.
Yep.
If it's B, if it's half of A, wouldn't it just be half of A, which would be B?
Sorry?
And then it'll be B squared as the area of the smaller.
Are you talking about the length of this?
Yeah.
Yeah, so you're saying it would just be half of A?
Yeah, which would be B, right?
No, let's look at this, right? Let's give some dimensions to
Isn't it a
this.
square though?
It is, but let's give some dimensions to this. If this is 8 meters long, right? Let's say a tennis court is 8 by 2. Let's just, I know it's not that narrow. It's probably more like 10 by 4, right? Let's just go with, I don't know how long it is. So say it's 10 by 4, right? So you're going, if it was half, it would be 10 by 5, right? You with me? But let's go with it's this, because you're saying, well, it would be half, right? You're thinking it has to be this. This is where we use variables, because if it's 10 by 4, it's still going to be 14 meters by 14 meters, right? And if that's 14 by 14 meters, right? That means this length here would be 6. That would be 6, and that would be 4. So it doesn't have to be half. I mean, it could be 8 by 2. That could be 10 meters. That could be 10 meters. If it was 8 by 2, that means that would be 8 meters long. That would be only 2. Therefore, this would be 6 meters length here. Again, it could be like 10 by 2. If it was 10 by 2, it'd still be 12 by 12. But that would be 10 meters, and that would be 2, leaving this with 8 meters here. So no, it doesn't need to, it can't be half, if that helps. It just looks like it in the diagram. Does that answer your question?
Yes.
Yep, cool. So let's look at, and algebra does get pretty tricky. So write an expression to find the inside area. Well, if I know the length and it's going to make a square, it's just going to be that squared. Subtract your answer from part B to find your answer. Subtract your answer from part D to find your answer to part D to find the area of the 4 courts. So this is typically what normally you'd get a question like this and it would just say find out the area of the 4 courts. It wouldn't take you through these steps to help you get the scaffolding there. That's kind of what we would expect you to be able to hopefully tackle in year 10. Just saying, hey, what are the area of these 4 courts in algebra, basically, and express it as an equation. So, well, I know the total area of this thing is a plus b squared, right? Like that's the whole thing. Because remember, when you times this by this, it's going to give you an array which covers the whole area. And that's why I like that area model. So when you go a times b, you're going to be calculating everything on the inside, right? But then we're going to take away just a little bit in the middle, which we already know the area of, and that will give us it. So really, the area is a plus b all squared. That's going to give us the total area of everything all over here. Then we're just going to minus the little bit in here, which we calculated as a minus b all squared. So now it just depends on how big your courts are. So if you change your courts or you change your sizes, you can figure them out. Unfortunately, tennis court's fixed, so it probably doesn't help. Find the area of 1 court. Does your area confirm that your answer to part E is correct? So really, if we want to find the area of 1 court, how can we find out the area of 1 court? Well, the area of 1 court would be what? Isn't it just A times B? Because 1 court's just A times B, right? So we know it's AB. Now, how does that help us with this? Notice that we didn't actually answer E correctly. If we expand this, and then when you'll find A plus B squared would give you, well, A times A would give you A squared. And it would give you 2AB, because A times B and B times A would give you AB. And then it would give you plus B squared. That would be it once you expand it. Then we've got minus A times A would give you A squared. Negative B times negative B would give you B squared. And then you'd get A times negative B would give you negative AB plus A times negative B times A would give you negative 2AB. So that would be minus 2AB. I'll fit this in. Right. Now, don't forget that's minus. I've put that in brackets. So yep, minus A squared plus, oops, that would be minus b squared minus minus will make a positive plus 2ab. So that would get rid of my, because I'm minusing a squared minus a squared leaves you with nothing. So that's gone. B squared minus b squared leaves you with nothing. 2ab plus 2ab leaves you with 4ab. That is the area of just the 4 chords. Now, if you've got 4 chords, divide that by 4. That's the area of 1 chord. So you can see we're right. Hey, that was a fun question. Thank you for that. I'm going to leave that review there on those ones.